We left off the last lesson discussing request scopes and how a new instance of the provider is created exclusively for each incoming request and garbage collected after the request has completed. To better understand request scoped providers, let's look at our coffee service again and make sure it's still request scoped. Let's double check that we still have that console log in our coffee service constructor so we know each time it has been created. With all of this in place, and our application running in the background, running npm run star dep if it isn't, we can see that even after our application bootstrapped, we didn't see any logs that our coffee service was instantiated, which is exactly what we should expect, since we haven't requested any API endpoints that use this service yet. Let's open Insomnia and execute 3 HTTP GET requests to our coffee's endpoint. Now, back to our terminal again. We can see that there are 3 messages logged saying coffee service instantiated, which means that this service was exclusively created for each request. Perfect. But wait a second. How is it even possible that coffee service was created 3 times, although our coffee's controller, which handles these endpoint requests, is a singleton, since we never change anything in the controller decorator for it? Well, in Nest, these scopes actually bubble up the injection chain. This means that if the coffee's controller depends on the coffee service, which is request scoped, it implicitly becomes request scoped as well. To test this behavior, let's add a single console log to our coffee's controller constructor to have a verbose log in the terminal every time an instance of the coffee's controller class is created. Let's save our changes, head back to Insomnia, and execute those 3 GET requests again for the coffee's endpoint. Now we can see that there are 6 messages in our terminal, 3 from the service and 3 from the controller, which means that both were exclusively created for each request. Great! There is actually one more extra capability of request scoped providers. Request scoped providers can inject the original request object. This is useful if you need access to request-specific information, such as headers, cookies, IP addresses, etc. Note that with this great power comes great responsibility. Using request scoped providers may have an impact on your application's performance. While Nest tries to cache as much metadata as possible, it will still have to create an instance of your class for each request. This might slightly slow down your average response time and overall benchmarking results. Unless a provider must be request scoped, it is always recommended that you use the default singleton scope whenever possible.